Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our first lesson for Chapter 7, Lesson 7.1.1. This is titled Distance, Rate, and Time, and we're going to use this, which is referred to as the distance formula, often called as D equals RT, which the R and the T are being multiplied together, and you can figure out the distance by multiplying the rate of speed times the amount of time. Okay, so first off, the distance formula is a proportional equation. This is proportional, right? If you spend no time traveling, you will go nowhere. So 0, 0 would apply in this situation. And the R, which is the rate of speed, is kind of like your unit rate in this situation. So it is definitely proportional. And it's used to find either the distance, the rate of speed, or the time it takes to travel somewhere. If you know two of these variables, you can always use algebra to figure out the third, okay? So I do want to say something. I'm changing this up a little bit from our normal routine. Normally, I go with a lesson that is in the book, and we work through the process, and we stick true to CPM. I have to tell you, this is the one CPM lesson that is just really confusing. I don't like it. It's overcomplicated, and I'm making an executive decision. I'm going to do something else. So I went and I found some different resources, and today, in some ways, I hope you don't like this a lot more because I don't plan on doing this again. It's a lot of work. But I like the way that this lesson turned out, and I borrowed some ideas from some other people, and we're going to go with it. First thing I borrowed was the fact that this was created by someone who wanted to have some sort of a sports theme for their students. So that's where I copied and pasted a little bit of stuff, and I did not get rid of this whole locker room thing. Okay, so just go with it. There's a 49er football theme, I think, going on with this particular lesson, and none of that has anything to do with the distance formula. It's just window dressing. That's all it is. But whatever. Let's just move on and let's get to the lesson. It says distance. Distance word problems, often called uniform rate problems, involve something traveling at some fixed and steady pace, or a uniform rate of speed. Okay, so fixed and steady means uniform, and the pace is like the rate or the speed. Or else moving at some average speed. Whenever you read a problem that involves how fast or how far or for how long, you should think of the distance equation, D equals RT, where D stands for the distance traveled, R stands for that average or constant rate of speed, and T stands for the amount of time. Now, as we're working through these problems, I don't think there are any of them that are too complicated in this particular lesson, but this is a fair warning for everyone to pay attention to. You need to make sure that the units for time and distance agree with each other, or agree with the units for rate. For instance, if your rate is in miles per hour, then your distance has to be in miles, and your time needs to be in hours. Okay? If they give you a rate of speed in feet per second, then your time must be in seconds, right? And your distance must be in feet. Sometimes they will try and trick you by using the wrong units, and you have to catch this and convert it to correct units. So for instance, they might give you a rate of speed which is in feet per second, but then when you declare your answer, you've got to give your answer in a number of miles. So you would have to do the conversion from feet to miles, and it makes things a little bit more complicated. But I've purposely not done that today. We're just going to go over the basics of how this formula works. So here's an example. If you are traveling for 3 hours at 65 miles per hour, how far will you have gone? Well, the first thing you always want to do is start with the formula, D equals R times T, or D equals RT. Then we want to start with the whole defining and describing everything. You got a distance, you got a rate of speed, and you got a time, and we're going to define these as, we know the rate of speed is 65 miles per hour, so we'll write that in. We know the amount of time is listed as 3 hours. It's the distance that we are missing. So we plug that information into the formula. If d equals rate of speed times time, it doesn't really matter which order you put them in. This is telling us we have to find the distance, we have to multiply 3 times 65, and the answer is 195. So if it's 65 miles for every hour per hour, then 1 hour is 65, 2 hours would be 130, and 3 hours would be whatever 3 times 65 is. In this case, it's 195. So this is actually a pretty straightforward, simple process. We could complicate matters a little bit by changing units of measurement and forcing you to convert. Or we could add decimal and fraction numbers, and you would have to work around the fractions and the decimals. That will happen sometimes too. But once again, I'm trying to keep this as straightforward as possible. You know you're allowed to use your calculators, so fractions and decimals should not hinder you as you work through the process. So when this is doing the problem, and this is declaring the answer. And of course, it's always good to check to the decide portion where does your answer make sense, kind of a thing. But we definitely, we work through the 5D process with these types of problems as well. Okay, so let's take a look at the situation. You are traveling to Sacramento, California from Los Angeles, about 375 miles by train. If the train travels at an average speed of 30 miles per hour, how long will it take to reach Sacramento? Okay, so these are the steps. First thing, write down your formula, D equals RT. Okay, then substitute the known variables, plug those in, and what they're not saying here is you should have defined it. You should have said D is equal to 375, R is equal to 30, and it's the T is the variable we're trying to find. So we're sort of skipping that a little bit, but that's okay. I'm a slave to this this lesson that I found, and we're just going to go with it. And we work through the process. Remember, if 30 times T is equal to 375, then 375 divided by 30 will tell you the value for T. So we will divide by the rate of speed, and you get 375 divided by 30 is 12.5. So now we declare our answer. It's going to take about 12 and a half hours to get there. Okay, and the reason they say about is because this is an average rate of speed, so they speed up, they slow down. If the average is around 30, even if it is 30, it may not be 30 constantly throughout the trip. So that's an estimation, but it should be fairly accurate, 12 and a half hours. Maybe a little sooner, maybe a little later. All right, this is a wonderful type of a problem that takes our problem solving to a new level. Okay, so D equals RT is very straightforward, but let's just pay attention to what's happening in this problem. Doug and Wanda leave their home in Chattanooga at the same time. They travel in opposite directions. Okay, so maybe one's going north, the other's going south, or one's going east, the other one's going west. Opposite directions. Okay, so here's Doug in his truck, there's Wanda in her little minivan, and Doug travels at 80 kilometers per hour, and Wanda travels at 72 kilometers per hour. The question is, in how many hours will they be 760 kilometers apart? Okay, so basically, this is how you need to think about it. If Doug and Wanda are traveling in opposite directions, in 1 hour, he has gone 80 miles, and in that same hour, she has gone 72. So if you think about it, after 1 hour, it would be 152 kilometers apart. So the fact that they're going in opposite directions forces you to consider that the rate of speed at which they are separating from each other is the sum of their two speeds. It would be 152 miles per hour. Like if Wanda was just standing right in front of her house and Doug took off going 80 miles per hour or 80 kilometers per hour, and he's going at 80 kilometers per hour away from her, right? Same thing. If Doug is standing there and Wanda travels at 72 kilometers per hour, then just standing there, he's motionless. She is traveling at 72. But if they leave their child in the driveway and both of them drive in opposite directions, as far as the child is concerned, their combined speed of now that's a horrible let's forget it. We're not going to go there. All right. So what do we have going on here? This situation ends up being the sum of their two speeds ends up being 152 miles per hour. Why do we not show that that ends up being 152? Is that what we're going to show right there? Yes, 152 every hour is how far they are apart from each other because of their speeds and going in the opposite direction. And so how many hours will it take before they're 760 miles apart? Well, now we're going to solve that by dividing, and the answer is going to be about 5 hours. They will be that far apart from each other. So this is taking the D equals RT, the distance formula, into more of a complex problem-solving situation where we just use kind of a little bit of logic that wasn't all that logical at first. But now that you see it, and think about them leaving their poor child in the driveway. No, forget it. Sorry. Moving on. All right. So let's do some practice. We're going to do about 4 practice problems, and then we are going to do 4 for real problems. And they're all practice if you want to be honest, but I'm going to work our way through these 4, and then I'm going to ask for you to pause and do the last 4 on your own, just to make sure that you understand basically what's going on. All right, so first problem says a car carrier is traveling 442 miles from Tokyo to the port of Long Beach with new Toyotas. Okay, so the distance from Tokyo to port of Long Beach is way more than 442 miles, but they are within 442 miles of the port of Long Beach, and they originally were in Tokyo. Okay, so the ship travels at a rate of 22 knots, which is called nautical miles per hour. That's what a knot is. How long will it take for the ship to reach the port? So let's start with D equals RT. We need to define and describe what we've got going on here. So the describe will always be what is the distance, what is the rate, what is the time. All of these problems have those 3 variables that we need to define. So in this case, we've defined our distance as 442 miles. We know that. We also know the rate of speed is 22 knots. It is the time that we do not know. So if you know 2 of these parts, you can figure out the third by setting up the equation. T equals RT, where R and the T are being multiplied times each other. So if 22 times T equals 442, then 442 divided by 22 will tell you the value for T. So we will divide 22 on both sides and use your calculator. You will see that you end up getting a repeating decimal that is very, very close to 20. So we will say it should take about 20 hours to reach the port of Long Beach. So the great thing about the distance formula is you don't have to go through that big process of combining like terms, doing distributive property, adding or removing balanced sets. With the distance formula, for the most part, with the exception of those complicated ones where Doug and Wanda are driving in opposite directions, for the most part, it's one step only. It's a division process. You take this number divided by the number that's being multiplied times your variable, and you get your answer. Let's try it again. New Toyota cars will be sent to New York by train about 2,850 miles. The train will travel at an average speed of 50 miles per hour. How long will it take for this train to get to New York? Okay, E equals RT again. We're talking about a distance and a rate of speed. We're asking how long it'll take. That is time. The distance formula applies to the situation. So do we know the distance? Yes, we do. Do we know the rate of speed? Yes. Hey, what happened? You're supposed to be there. Yes, we do. It's 50 miles per hour. It is the time that we don't know. So let's plug in the formula. E equals RT. And what do we have to divide by? 2,850 gets divided by 50. So we can find out the value for T. What is 2,850 divided by 50? It is 57. So we can declare our answer. It will take 57 hours. Okay. So far, so good. Pretty straightforward. Let your calculators help you along the way. Let's go to problem number 3. Joe rides his bicycle at a speed of 8 miles per hour. How long will it take him to ride 28 miles? Okay, so we know the distance? Yeah, it's right there, 28 miles. Hey, give up. Do we know the rate of speed? Yes, it's right there. It's in miles per hour. So our time is going to be in hours. So we know D is equal to 28 and R is equal to 8. What is 28 divided by 8? That gives us an answer of 3.5. So we can declare our answer. How long will it take for him to ride 28 miles at this rate of speed? It should take him 3.5 hours. All right, let's try a complicated one. Two trains leave Bridgeport at the same time. One is traveling north, the other is traveling south. The first train travels at 40 miles per hour and the second at 30 miles per hour. In how many hours will the trains be 245 miles apart? Okay, so remember, if you're at the train station and you're watching the first train head north, you see it taking off at 40 miles per hour. If you look at the train heading south, that one's going 30 miles per hour. But those two trains relative to each other, traveling in the opposite direction in 1 hour, will be 70 miles apart. So the relative speed of them combined is going to be 70 miles per hour. So what is the distance? 245 miles. What is the rate of speed? Well, when you combine them, it ends up being 70 miles per hour. So how many hours will it take before they are 245 miles apart? Now you can do some estimating here, right? In 1 hour, they're 70 miles apart. In 2, they would be 140. In 3, they would be 210. So we're looking at somewhere between 3 and 4 hours. But we'll just set up the equation, divide by 70, and what do you get? You should get 3.5 hours. So there you go. It will take 3.5 hours for them to be 245 miles apart. All right. I think we're ready. How much time have we spent so far? That's not too bad. All right, 4 more problems. Let's get to it. I'm going to leave it right there for you, and I would like for you to pause, and I'd like for you to copy everything down, work through the process, and declare your answer. And then we'll see how well you got your answer. And then we're going to do this for each one of them. So we'll pause along the way, and then do your work, and then unpause for the reveal. All right, let's see how you did. Pat's driving at 80 kilometers per hour. How far will she travel in 2 hours? Okay, this is a little different where we have to figure out the distance, but we've got the rate of speed and the time. So in this case, for the formula, you're actually just going to multiply. There will be no division. And 2 times 80 is 160. So the answer is that Pat will travel 160 kilometers. Problem number 2, go ahead and pause. And then unpause when you're ready for the reveal. All right, let's see how you did. Marilyn traveled 240 miles. What was her rate of speed if she made the trip in 6 hours? All right, so we've got our distance and we've got our time. It's the rate of speed that we don't have. So when we set this up, it's going to be 6 times r is equal to 240. So we're still going to do a division here, but when we declare our answer, it's going to be a rate of speed, not a time or a distance. And since our rate of speed has to combine the miles and the hours, it's going to be miles per hour. And if you got 40 miles per hour, you are correct. Marilyn traveled at a speed of 40 miles per hour is the correct answer. All right, Rudy. Oh, no, I'm going to let you pause it and read it. You can work through the process. All right. So Rudy rode his bicycle 72 kilometers. That's our distance. How long will it take if his rate of speed was 9 kilometers per hour? So we've got the rate of speed. It's the time we have to figure out. So set up 72 is equal to 9 times t. And 72 divided by 9 is 8. So that means we can declare that Rudy took 8 hours to complete his bike ride. All right, this last one, this is a tricky one. I want to see if you can figure this one out. It is not exactly the same as the other two situations with Doug and Wanda driving in opposite directions and the trains going in opposite directions. In this case, the two cyclists are traveling in the same direction on the same course. One travels 20 miles per hour, the other one travels 14 miles per hour. After how many hours will they be 15 miles apart? Take your time on this one, okay? This can be a little bit tricky, but it is logical. And I'll explain the logic if you struggle with it. And if you don't struggle with it and you get it, congratulations, good work. Okay, so go ahead and pause it and see if you can work this one out. All right, here we go. Two cyclists. They want them to be 15 miles apart, correct? Now, here's the thing. When we were dealing with Doug and Wanda in the van and the truck, they were traveling at different rates of speed away from each other. So after 1 hour, they were like 100 and some odd miles from each other. What was it, like 152 miles from each other? So that was like the relative speed of both of them traveling in opposite directions. But if two cyclists, if they're riding side by side in the same direction and they're going the exact same speed, then it's kind of like relative to each other, their speed is 0 miles per hour because one never goes faster than the other. And so they would get to where they were going at the exact same time, the same number of hours. If one person is traveling 1 mile per hour faster than the other, then that's kind of like their relative speed. So what's happening here is every hour that they travel, this person, this one traveling 20 miles per hour will be 6 miles ahead of this one because they're going faster. So think about in terms of one mile per, in 1 hour, how much farther will this person have gone than this person? Their relative speed ends up being 6 miles per hour. And so the time that it's going to take is going to be based on the 6 miles per hour. So 15 miles at 6 miles per hour is going to be the gap between them. For 15 miles means you're going to take 15 divided by 6, and it should take 2.5 hours before they're 15 miles apart from each other. Okay, so these problems that involve either adding or subtracting the speed, that's a little bit advanced. That's not a kind of a problem that I really want you to focus on in 7th grade math, but it does extend your thinking a little bit, and it is good for problem solving. But if you can do the basics of all these other problems, where you just plug in the D or the R or the T, the two that they give you, and then solve for the third, then you are mastering the 7th grade concepts here. Okay, so congratulations, hooray, touchdown, whatever that means. We are done with our lesson, and I think we should have a check for understanding because I want to see how well you're understanding this, but I have a feeling people are going to do really well with this, right? Take care, bye.
Hey, feeling good.